Good afternoon. So, having a look at reflections in the x and y axis. And we're doing questions 1AC, 2AC in this video. And it's the same for both courses. So, we've got, for 1A, we've got y equals x squared take 2x. But what they want us to do is replace y with minus y. So instead of y, I'm going to do minus y. Negative y equals x squared take 2x. Now, yes, they told me to sub that in, but no, I can't just leave it there, because you can never leave something with negative y equals. I need to end up with just y equals. So we're going to divide to get rid of this negative 1. So you get y. Don't forget when you're dividing by negative 1, you do it individually. I'm going to write this step out, you don't need to. So that's going to give us negative x squared plus 2x, same as 2x take x squared. For 1c, they say to sketch it. So, let me get some nice paper. You never do this well, by the way. Never put too much effort into this. So we've got x squared take 2x, which is the same. So y equals that. That's the same as x outside of x take 2. So its intercepts are at 0 and 2. So it's y intercept x, y equals 0, 0 take 2, so the y-intercept is 0. X-intercept 0 equals x, x take 2, so x equals 0, x equals 2. And the axis of symmetry, halfway. So we have 0 plus 2 over 2, so it's just going to be 1. And the y-coordinate, sub in x. So y equals 1, 1 take 2, y is negative 1. So we're turning here. That looks like a weird face. Okay, so it's going to go like that. It's going to go like that. So that's y equals x squared take 2x. Now, I'm going to do essentially the same thing, but in purple. So that's the same as y equals x negative x plus 2, which is the same as x to take x. So y-intercept, x equals 0, so y equals 0. X-intercept, x equals 0, and x equals 2. Axis, halfway between, x equals 1. Y-chord, y equals 1, 2, take 1, so y equals positive 1 this time. So I'm crossing over here, here my axis of symmetry is here, but now the y-coordinate of it is here, so a sad face, yoink. And you can see pretty clearly now that this actually comes out as, and this is just a rough job, like that, and then the other one's just that one upside down. So it's been reflected in the y-axis, in x-axis, when it's upside down. Question 2, fairly similar. So, for 2a, we've got negative y equals 2 over x take 2. Oh, sorry, I didn't read the question. We want to replace x with negative x. So this time we've got y equals 2 over negative x take 2, which is the same as y equals 2 over negative x plus 2. So y is negative 2 over x plus 2. Cool. For 2c, we're going to sketch. So I'd just like to remind you, if we had 1 on x, the asymptote x equals 0, y equals 0, so it would look like this. Yoink, yoink. For 2 over x take 2, we're still going to have our axes. The x take 2 means that we've got an asymptote it's been moved right 2, so x equals positive 2. It hasn't been moved up or down, so y still equals 0. So this time, it's going to go like that. I'm not going to be too accurate. And the y-intercept, nope, they haven't asked me to find the y-intercept. So I'm going to leave that alone. 4, y equals negative 2 over x plus 2. The asymptote, x equals negative 2 this time, but y is still 0. It hasn't been moved up or down. The negative 2 is because of this. So actually, do that in green. So I'm going to mark that on. And the negative out the front means that this time, I'll do this in purple. Instead of going yoink, yoink, the negative, so yoink, yoink. So you can see for that, I've essentially, if I get rid of this purple one, and I had this green one, I'm just trying to figure out how I can grab the green stuff without the axis as well. And I've essentially, I wanted to make it bigger, sorry. I've essentially flipped it over. So instead of being here, I'm now here, and instead of being here, I'm now here. That's all. That's questions 1A, 1B, C, 1, 2A, 2C.